All right, welcome to The Explainer. Today we're diving into something, well, it's both fascinating and a little bit unsettling. We're talking about a huge vulnerability in AI, but it's not hidden in lines of code. Nope, it's out here, in the physical world.
So, let me paint a picture for you that really gets to the core of this. You're in a self-driving car, right? It's cruising along, comes up to an intersection. The camera sees the big red stop sign, but what is the AI brain actually seeing? What does it think it's seeing?
And here's the crazy part. It's not a bug or a glitch. It's a trick. With just a couple of small, cleverly placed stickers, an attacker can make that AI completely misread the sign. It sees stop, but it understands speed limit 80. I mean, you don't have to think too hard to imagine how badly that could end, right? And this isn't some sci-fi movie plot. This is a very real problem, and it's pushing cybersecurity into a whole new territory. So let's break down what's really going on here. So you've got to be asking, how is this even possible? I mean, how can a few pieces of tape or a weird-looking pattern completely fool an AI that's supposed to be super sophisticated? Well, this whole phenomenon has a name. All right, let's get into the weeds a bit. It's called a physical adversarial AI attack. Think of it like this. It's basically an optical illusion, but it's not for us. We might not even notice it. It's a special kind of illusion created just to trick a machine's eye. Now, what's really key here is understanding the difference between a digital attack and a physical one. See, a digital attack is kind of easy. You're just messing with pixels in a clean, perfect computer file. But a physical attack, that's got to work out here, in the real world. The messy, chaotic, unpredictable real world. It has to be tough enough to work no matter the lighting, the angle you see it from, or how far away you are. And pulling off one of these attacks, it's a pretty slick process. First, the attackers have to be like detectives. They study the AI model, figuring out its weak spots, its visual blind spots. Then, they use these powerful algorithms to create the perfect little pattern, they call it a patch, that's designed to disrupt everything. But they're not done. They have to fine-tune that patch so it works in the real world, from all angles. And then, finally, they just print it out, stick it on the object, and wait. Because let's be real, once you can fool a car's AI, you start to realize just how far this can go. The consequences just ripple out. We're not just talking about traffic signs anymore. This has massive implications for things like military defense, for cybersecurity, and yeah, even for your own personal privacy. So just how good are these attacks? Well, get this. In one study, those little black and white stickers we talked about, they caused a self-driving car's AI to get the stop sign wrong almost 80% of the time. 80%. That's a mind-blowing failure rate for something so important. Now, take this to the military. You can use these exact same ideas to create what's called adversarial camouflage. You slap a specific pattern on a tank or a jet, and suddenly, it's invisible to the enemy's AI-powered surveillance drones. It's basically a real-life invisibility cloak, but for machines. And hey, this isn't just about what an AI sees. It's also about what it reads. You can apply the same adversarial tricks to language models. That means you can create these incredibly convincing, hyper-realistic phishing emails that just sail right past your spam filter. It's a way to automate identity theft and fraud on a scale we've never seen before. It even comes down to our personal lives. Researchers have actually created patches you can wear on your clothes that make you practically invisible to surveillance cameras in public. And it gets crazier. There are even makeup patterns that can fool facial recognition software. I mean, talk about raising some serious new questions about our privacy and what security really means. Okay, so with all these threats out in the open, the race is definitely on to build a smarter, tougher AI. So what's the game plan? How are we fighting back and making systems that can't be tricked so easily? Well, the first line of defense is all about having multiple layers. For starters, you've got to train the AI on images that include these attacks. You basically show it the tricks, so it learns to spot them and ignore them. Then, you use more than one type of sensor. You combine the camera data with stuff like LiDAR or radar, so the system isn't just relying on its eyes. And of course, for the really big decisions, you always want to keep a human in the loop. That's a must. But it goes beyond just general strategies. Researchers are now building some seriously specialized tools to combat this, and one of the most exciting ones is a system called PhiSense. The whole idea behind it is to give AI a big old dose of real-world common sense. So what's so special about PhiSense? Well, it's pretty clever. It doesn't just look at an object by itself. It uses common sense. It asks questions, Like, does the way that thing is moving even make sense in the real world? Is it the right size and shape? And this is the big one. How are other things reacting to it? Basically, it's doing a reality check. Does what the camera sees actually match up with the basic laws of physics? But look, none of these defenses are a perfect solution. There's no silver bullet here. Just like with any kind of cybersecurity, the second a defense goes up, the attackers are already looking for a way to get around it. It's a constant, back-and-forth AI arms race. What we're really looking at is this classic game of cat and mouse. The defenders build better training, right? But that training usually only stops the attacks we already know about. Totally new, unseen attacks can still slip right through. And there are even these things called blind spot attacks that are designed to find the exact little gaps in the AI's knowledge, and they can fool even the most robust systems. And this all brings us to one final, really important question. As AI becomes more and more a part of our physical world, I'm talking our cars, our security systems, our entire infrastructure, how do we make sure we can actually trust it? How do we guarantee that when a machine looks out at our world, it's actually seeing the truth?